All right, so here's where we're at now. The BIOS on this machine has a limit of around 500-ish megabytes, I think, which means that any drive bigger than that will never report the correct size. We will always be limited to that. The drive that I thought was a 512 megabyte or 500-ish megabyte drive turned out to be 130. We're going to hang on to this for another project. That could be the spare hard drive for the Toshiba T3200. So what I'm finding is any disk does not support, for some reason, I can't get any disk to work. The drive I really want to use is this one. This is a Quantum BIGFOOT 4.3 gig drive, and yes, I know these have reliability issues. Yes, I know they're slow. No, I do not care. This is what I want to use, so that's what we're going to use. What's nice about this drive is it will fit straight away into one of the 5 1/4 inch bays, and I can daisy chain it with a CD-ROM drive, and bada boom, bada bing, Bob's your uncle. So that's what we're going to use. To make it work, I've obtained a copy of Western Digital's version of Easy Drive, which is, I believe, made by OnTrack. And this is a utility that I have used in the past, but I have since lost my original disk, but thankfully I found a copy on the web. So I'm now creating the bootable Easy Drive disk on this machine down here. I toyed with the idea of actually going to the trouble of trying to find an updated BIOS for this motherboard, but I don't think that's going to happen. I don't believe it is a flashable BIOS, and I'm not sure even updating it is going to really fix our problem. I really want to use a lot of period correct hardware in this machine, and that's where I'm headed with this. So updating it to a VL bus motherboard, which would have all the new better BIOS software, better support for other hardware. I'm not going to go that route. I want to keep this an early 90s, somewhat period correct machine. Of course, we're going to go ahead and put this 1995 sound card in here. If this sound card is damaged, if you didn't watch that, I put one of the new caps in backwards by accident because I misinterpreted the symbol on the board, and it was completely my fault. Obviously, I own it. It is my fault. My bad. But I think the drive, I think we replaced the blown up cap. I think it's going to be fine. Hopefully. I mean, it blew immediately. I hit the power switch and boom. It was just that quick. So, take this zip tie out of there. It looks like we could potentially put a faster clock crystal in here. What do you think? No, I don't know if that's even a thing. I don't recall ever hearing about people doing that. But once I get this thing stabilized, once it's out of intensive care, I am going to consider putting in a DX2 chip. That is my plan. So we're now writing. So this machine has come in clutch. I'm glad I have this thing. But we do need to rebuild this PC. This thing has problems that we we need to address. I'm going to do a clean build of Windows 98 on this at some point in the future. I think once I get this machine up and running, I'll focus my attention on kind of restoring that one. So there we go. Let's get this built. Almost done. There we go. Okay, so what I'm going to do, I've got all the jumper settings all put in properly and all that happy stuff over here. I don't know what the correct orientation of this drive is in this desktop case. I really don't. Nor do I care. All right, here we go. So let's see if the Easy Drive is bootable. Yeah, okay. So we have to run the setup utility. This has been off for quite some time, so we need to go and do all the things we got to do. All right. Hit escape to stop now. Any other key, continue. So what I need to do is configure it for, notice how it defaults to a 1.2 meg, 5¼ inch. This is an old board. This is probably from 1991 at least. Now I'm gonna say 91. So with Easy Drive, now watch this. I can put in, I have them written down on a post-it somewhere. I thought I carried it with me. No, that's not it. But I definitely have the drive parameters written down here somewhere that I can just, because they're not written. Oh, they are written on the drive. Okay. Ooh, static. All right. 4.3 gig, 8960, 1563. Now, watch this. 8960. So 15 heads, 63 sectors per track. Now watch what happens. It acknowledges it as a 4100 megabyte drive, but here's the problem. It doesn't work. There I said it. It doesn't work. I wouldn't expect it to. Again, this board is old. I mean, in 1991, when this was a new board, and I think that's about how old it is. The biggest hard drives you would typically see in a consumer class computer were something around, I'd say something in the 250 to 300 to 400 megabyte range. 400 being top of the heap. But you typically see a smaller drive size back then, something in the 100 megabyte to 300 to 400 megabyte range. You know, that's about what you would expect to see. So this board did not, his BIOS was not written with this drive size in mind. So just bear with me on this. It can calculate it, okay? It's able to calculate the drive size properly, but that does not mean it acknowledges it. Now it sees all 8 megabytes of RAM, which is kind of interesting. It's done that before. It doesn't mean there's anything bad. It's just a characteristic of the board. Also find that it's slow to boot from a floppy. Up there it goes. Okay, it's booting. Movie starting. Shh. Put the popcorn down. Movie starting. Loading Easy Drive, please wait. But any disk did not work for me. I thought it would. I've used it before. It worked on my Toshiba without issue. And I think I used it on my Tandy, if I'm not mistaken. I forget what I used on that one. Is this on a 720K? No, so it wasn't this disc that I used. All right, I'm gonna go grab my phone stand. So with the drive overlay program, you can pretty much use any BIOS setting that it will support. It's not an issue. So you do not need to use fdisk and format programs. Easy Drive will also check your BIOS to ensure that it is capable, blah, 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 blah. Press any key to continue. This is licensed to Western Digital for OEM use only. Okay, so let's do, yep, it sees the hard drive right there, so we'll do fully automatic. Yes, I want to erase it. Just a note, this hard drive actually came with my Windows 98 PC, the very PC that I used to make this disk. It was the original drive to that system from 1997. To access the full capacity of this hard drive, you need to install Easy BIOS, so we will hit yes. Okay. Insert DOS system disk or Windows 95 startup in floppy A. So we're going to need our DOS 622 diskette to continue, which I have right here. Nope, that's not it. Oh, it's right here. So I have decided, I've made an executive decision that we're going to stick with Windows 3.1 on this build. I just feel more warm and fuzzy with a Windows 3.1 desktop rather than 95. I hope that sounds fair. So it's going to partition first and second as 2145, the limit of FAT16, and there will be a third partition for so here's what I want to do. I'm going to change the partition sizes. So disk 1 is going to be 1000 megabytes, or partition 1. Partition 2 will be 1000, and the last one will be 2145. That way they're more usable. I don't want a 39 megabyte useless partition just hanging out there. So, oh, partition 4 will be 186. But how do we divide that evenly? Let's see. 4 point. What is it? Fourth. All right. It's escape to cancel. Enter new sizes. I just don't want that useless 40 meg. It just doesn't sound right to me. So we got 4328 divided by 3. That's what I'm going to do. So what it's doing is it's automatically sizing them to the maximum. So 4328 divided by, how about 3? That's 1442. Okay. That works. So we got a 1440, 1440, 1448. Perfect. Okay. So it's going to take care of everything for us. It's just going to do it for, it's just going to make the world work. Now, I have other drives I could use. I've got a 12 gig version, or I think it's a 12 gig version of the Bigfoot. But I want the older one because I want the system to be as old as possible using parts made in that. Can you understand what I'm getting at? Now, before anyone suggests this, and I know you will, we're not doing a flash drive thing in here. We're not doing the solid state thing. That's not the purpose of this project. This is not going to be a solid state showcase. This is going to be a showcase of Jurassic parts, including the hard drive, and I don't care how you feel about that. So, that sounded really mean. I don't mean to be mean, but it is what it is. Okay. So the hard drive is formatted and ready for use. Let's see if this worked. Press escape to restart your system. Alright. So that means that it should have formatted it as a bootable drive. Here we go. Let's see what happens. Alright. Once I get Windows 3.1 installed, we'll have Easy BIOS is there it is. Okay, press A to begin OS install. So insert a disk, press a key. So now that the drive is theoretically formatted, MS-DOS 622 upgrade will automatically see that and say, "Oh, you're upgrading." That's how you get by the copyright limitation and all that shit. So this machine will be up and running today. With the 4.3 gig drive that I chose for it. That makes me a happy guy. That makes me happy. So, I'm still waiting for my IDE cable, so I can't put in my CD-ROM drive, but at least we can pick one out and fit it to the machine. So here's the one I'm going to use. I've also got a 5 1/4 inch drive that's going into this as well. Because why not? So I've got this Memorex 24X, or 48X actually. Now this drive is from about 1999 or so. 2000. A little on the new side. But I think it'll look nice in this case. What do you think? I've also got a couple of older nondescript ones. I've got a Yamaha. I don't want a reader, I mean a writer. Ah, here we go. I've got one of the most generic looking drives. It's a closer match to the case color. This, I think, is a Toshiba. Yeah, it's a 1997 Toshiba. Just their CD reader. Maybe that would be the better choice. Just for historical accuracy. A 1994 drive. I don't have anything that old. What are you kidding me? That looks nice. And that looks more appropriate for a system build of this caliber. So we could probably fit that one in there. We don't need a drive. So by using this hard drive, I don't need to obtain a 3.5 to 5 1/4 inch bracket. You continue setup and replace CDOS. I do need to put in a CMOS battery. So this uses one of those 4-pin units. Not a problem. They still make them. I can still get them, or I can make my own. Either way. They're a little pricey because they're only made for specialty applications, but this is moving along, guys. Yesterday was a nightmare. Today's going to be a new day. I love the sound of this hard drive. You hear it? It makes some of the strangest noises. But we're moving forward. We're going to do a major jump cut here. And I want to start by saying special thanks to Chris Lenderman of RetroTech Chris on YouTube. He was watching a live feed I had just done where we install the OS and we start finishing up, getting the major systems running and operational, bringing everything online, as they say. I ran into some difficulty getting the CD-ROM drive to work, and he was instrumental in providing me some feedback on that as to what to try, what to use, etc., etc. So thank you, RetroTech Chris. You're the guy. You're the man. You rock. I couldn't have done it without you. So let's backtrack a little bit. You'll notice that we put a 4.3 gigabyte Quantum BIGFOOT drive in this. Now, the Quantum BIGFOOT is a unique product. It was kind of a failed product, actually. There were, as far as reliability goes, I do remember them being hit or miss. And a lot of them did fail, and most of them, I would say most of them have failed early on in their lives. The one that I have, that I had installed on this machine, actually came from that computer right there. I have owned that drive for more than 10 years. I think I got that around 2013 or so. Yeah, that's how long I've had the drive, and I've never used it. It's a 4.3 gig, so plenty of capacity for really any use for something of this age. And, the drive was working when I pulled it, so I figured, what the hell, let's put it in. But the problem is, the BIOS on this machine only has a limit of around 500-ish megabytes. So, yes, you can put a much bigger drive in there as long as you do two things. You have to install an overlay like Easy Drive or OnTrack, but you also need to partition it into chunks, which I think we covered. I think we've covered that already. So let's put that aside. One of the unique characteristics of the Quantum BIGFOOT is its jumper settings. And I have a much bigger BIGFOOT, which I will use to show you guys. This is one of the later models of the BIGFOOT. This is from about 1999 or maybe even 2000. This one came out of a compact Presario desktop. I remember pulling this drive. And you'll notice, this one of the jumpers are up on top. But there's CS, DS, and SP in this one. So what I found is, and this is straight from Seagate, who actually supports or still has the literature on these drives after a couple of different mergers. You have to jump cables. No, you have to jump two. You need two jumpers. And I believe it's cable select and DS. Or something to that effect. But you need two jumpers on these for them to act as, and this is actually, I think, true for other quantums as well. I just don't work on a lot of quantums. Most of the quantums that I've come across in my career have been in Macs, and they were SCSI, and I never had to mess with them. Once we figured that part out, the next step was getting a CD-ROM driver that works to work with this CD-ROM drive. And I downloaded one off the web. It wasn't the Oak Technologies one. It was a different one. I can't think of the name of it. But it kept causing the machine to hang. And another thing I learned is when you're setting up a BIOS for a motherboard that was never intended to be connected to a CD-ROM drive, because CD-ROM drives did exist, but most of them were SCSI back then. And if they weren't SCSI, they used the sound card. A lot of the earlier CD-ROM drives were bundled with a Creative Labs or similar sound card. And the sound card is what provided the IDE chain. And then the drivers did their thing and everything was good. But this was another tip from RetroTech Chris, and I believe Scott Savage, who said that you have to set on the chain, basically set it as not installed. So when you're setting up the BIOS for these machines, you just select not installed. The driver will then find the drive and do its thing. Our 5 1/4 inch is installed physically, but not connected. I just had to order a longer drive cable, to make that happen. So the drive cable is too short, so I had to order a bigger one. Easy peasy, Japanesey. The drive I chose is a flaky Toshiba. I'm actually going to keep this drive in here because I think it looks period correct. I have other drives, but this one is the only one that looks period correct in this case. And besides, I'm not putting in any CD reading or rewritable functionality in here. So let's go ahead and power this thing up. The sound card that you saw blow up in video 2, guess what? It lived. It survived. That has been confirmed. The drive, or the Sound Blaster, is a good sounding, clean sounding card. Beautiful sounding card. Oh, what a great card that is. So let's fire it up. Now, I don't have a clock battery in here. So it does retain its settings for a couple hours without a battery, which is really impressive. There is no battery on this board, no that I can see. But there is a plug for it right over there. And it is empty. So we're starting Windows 3.1. Why don't we go ahead and install some software, right? Too many jump scares in my videos lately. Eesh. All right, so let's go ahead and let's install some software. I gotta put something under my phone. All right, another thing I noticed is the turbo function on this motherboard does work. And what you're gonna find, I got some DOS applications I want to put on here. But for the most part, what I want to do is we want to get, let's see what we got here, SimCity, Zaxxon, Stunt Car, Word for Windows, Workgroup, Excel. Here we go. Got Microsoft Excel, got LapLink, Excel. Got, I know I have Word 6.0. I'm going to put that on. A lot of disks. Okay. So we're going to go ahead and put Excel and Word from floppies onto this machine. I'm going to start with Word. It's about correct for the age. Word 6.0 was definitely created right around Windows 3.1's heyday. Let's see if this launches. So, got a few more things I also need to do. Our graphics board is not the right one. I didn't realize that I had bought one of the worst graphics cards you can imagine. So we're going to find another one. When you're building a machine to kind of fit a particular era, you can definitely fudge things to get better results. For example, nobody needs a 16 color 256K graphics adapter. Although at 256K it should still support 256 colors, you would think, right? Because no, I think you need 512K, 1 megabyte for 16-bit color. So yeah, we need a better graphics card for sure. That just has to happen. So not a big deal. $50 or so, I can definitely get a better one, and we can solve that problem. That will let me use at least, all I really want is something that I can easily get Windows 3.1 drivers for, which that should be the ticket right there. So this machine started out as a potential failure, as we saw earlier in that video too. Oh my God. Yeah, it spewed its guts like a party popper, but it lived. So, but yeah, the turbo, it is a unique feature on these earlier 486s and 386s. So you can slow it down. So if you're playing any earlier, like XT DOS games, that's really what that feature's for. So you can slow the whole thing right down, and it will better run those programs. So let's talk a little bit about the hard drive I chose. Now that was a choice. I have other drives I can choose. Not only do I have another BIGFOOT, but I also have a whole bunch of smaller IDE drives, or EIDE drives, that I could use. And this was more of a choice than anything. I've been wanting to put one of these BIGFOOTs into work, or to work, for quite a while. I've hung on to them for one reason or another, but I think it's like, now's the time. Let's just put it to work. Let's see what she can do. And it just fit the bill, you know. Another thing, I'm going to buy a bunch of matching slot covers so that I can better clean up the back of this case. It's kind of ugly, I think. I might actually have a case fan, a blower, that I might put in here. I know I have one that I kept from years ago. An unused, I believe, unused blower. It sits in one of the slots and it helps bring air into the case. Although it may compete with the power supply, and it might cause a disturbance in the force, because the power supply is an exhaust fan, and I think that blower might actually be an exhaust fan as well. So I don't know. We'll look at that later. So we got to get a graphics card. I've got a cable for this drive here. This is a 360K floppy. That's all we need. I don't do anything with 1.2 megabyte floppies. Never have. Let's see what else we got going on. RAM. I'm going to try to find a matching set of 30-pin SIMs. So according to the board manual, which I have over here, let me try to find that. Find that right here. Here are the specs. So, onboard memory can be expandable from 1 meg to 16 meg, or 48 if HD SIM RAM modules are used. Okay. So 486DX system board is based on the 486DX or SX microprocessor. So it looks like the board and chip are generally sold as a combo from the manufacturer, which is interesting. Another upgrade I plan on doing later on is I'm going to replace that 486DX33 with a DX266. It's kind of a no-brainer for me. It's still a 486 processor, but it's internally clock doubled to 66. And they are very fast. I generally put those in my 486 systems, at least I have previously. So we need to find some 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We need some 2 megabyte 30-pin SIMs. Those may be hard to find in 2023, but I'm going to try 2 megabyte 30-pin SIMs, a matching set. It doesn't say anything about error correction. Onboard battery backup for CMOS configuration table and real-time clock. 6 16-bit expansion and 2 8-bit expansion. Yeah, that's about right. So looks like we have the right manual. Now they spelled it memory ban. I think that's a typo. Ban 0, ban 1 and 2. SM1 to SM4. No, it's bank. Okay. All right. So what we're going to do is we're going to try to find a matching set of 2 megabyte 30-pin SIMs. You can change the 46 system board can run at either non-turbo or turbo. The selection can be done by either turbo switching button or using iBoard control. Control Alt plus, Control Alt negative. Okay. And these are the JP5, short or open. So this will support a CGA. That's weird. Who's building a 486 with CGA in 1991? I don't. Internal or external battery? JP7. There is no internal battery. JP7. I did not see a battery on this board, internal or otherwise. But it's way under there. Yeah, okay. The battery bank the battery plug is right there. But at no point do I see space for an internal battery. Maybe we'll read further in the manual and see if maybe there's like a rechargeable or like a super capacitor. They didn't have those back then. And I don't see pads anywhere for a battery. So I'm quite confused by that statement. But that's okay. We've ordered a battery for this, so that won't be an issue anyway. I'm not too concerned about that. So now that we got our CD-ROM drive working, it's time that we fix it. So this drive works, but it occasionally, more often than not, it just slips. It's almost as if the belt might be slipping. So what we need to do is take this apart and look at the load mechanism. Let's see if we can get that fixed up. But the drive works. This is a 1997 drive, so it's definitely of the era, although a little newer, but that's okay. Got my little screws out. I don't know what speed this is, but I'm assuming it's probably in the lower side, probably 12x. The model number is of very little indication. It's an XM602B, which could indicate one or the other, actually. I really don't know. I'll take this bottom cover off. Let's have a look inside her. Nice sound deadening foam. All right, the board's got to come out. And I'll take that out. Unplug this ribbon cable. Screw out. It's also a good opportunity to clean the CD lens when we're in here. I know that's dirty. We're going to have to desolder 2 wires here, and they're clearly labeled red and black, so that was smart of Toshiba to do that, make our lives easier. All right. So here we go. Take those wires out of there. Okay. I think I need to take this faceplate. Oh, you know what we need to do? We need to eject the there we go. I'm gonna pull this out. Hear that? That grinding? That's more or less just lubricant that has dried up, more than likely. So, all right. So this CD-ROM drive is basically your typical system builder. These are probably purchased in bulk. I think Toshiba's were the more common ones for the system builder packs. So I'm fairly familiar with those system builder packs. What they would do is your local computer store, just your little mom and pop shops. What they would do is they would buy components like this in bulk from wholesalers. And they'd come in generic packaging, like basically, you know, maybe 10 to 20 a box. And this thing's dirty inside. So they would buy these in bulk, and they would each come with a copy of this, you know, the driver and a little MSCDX driver. And they were pretty reliable little drives for the most part. Might as well do caps on this. We're here, and I think I have these on hand. The exact size I need. So we'll do caps on it while we've got it here. We're already, you know, in the thick of it. All right. Clean things up a little bit there. We're going to definitely want to clean that laser lens for sure. Yeah, this is just a fairly cheap mechanism. That's what it is. But it works. All right. So what's happening is it will partially clamp on the disc, and then you can hear the motor spin. So yeah, not great, but it's not the end of the world. And let's see if I can even get it apart. It looks like it isn't going to happen for us. I'm trying to figure out how this thing is put together. Yeah, there we go. Okay. Yeah, that works. To the other side. But yeah, we'll restore this drive. See, these are the kinds of parts that nobody really thought to save. Because, I mean, no one ever thought back then that these types of, you know, generic, you know, local mom and pop builder PC would ever be worth saving, you know. So what do we got going on here? So there's a motor here, and I suspect that it's belt driven. No, it is direct drive. Okay, I think we just need lubricant. That's all. Let's lubricate it. It looks like this part here might be melted on. Is that right? Okay. But if you've ever wondered what the inside of one of these looks like, you're looking at it. Okay, that laser lens is pretty gross. It's got a film on it, which is not a good thing. Just clean that up. Now, one of the things that I've learned about these early CD mechanisms, in fact, even later ones, is that okay, as the unit ages, it'll start to develop read errors. Usually, it's correspondent to the amount of time it's in use. You can actually gain a little more usability out of these by just slightly adjusting on the back of the laser block, the optical block. There's a little potentiometer there, and you want to just tweak it just a hair. I mean, I'm talking just like maybe 1 minute at a time. If you're looking at a 12-hour clock face, 1 minute at a time, just bump it in the clockwise direction. Do it 1 minute, try it. If it doesn't work, do it 1 more minute, try it. Still doesn't work. Once you've hit about 5 minutes or so, it's done. There's no more adjustment. It's just not going to help you. So what we need to do is we're going to clean this up real good. Now, this is not a belt drive.
What is it then?
It's a direct drive. So
What does it do?
all right, I figured it out. So you've got to take these little clips here, push them in. If it breaks, well, we'll just have to abandon the project. So hopefully it doesn't break on me. There we go. Got it off. Okay. So now we got this out of here. So like I said, I can hear the motor spinning here, but it's not clamping on the disc. So you want to make sure that this is all free of any obstructions. This is a magnetic clamping disc. So there's a magnet right here. Okay. But what I suspect is happening is it's not ramping up. So as this drawer slides in like this, you see how it raises up the mechanism like that? Okay. All right. So that means we just need to put a little bit of lubrication, I think, on this little ramp here. That's pretty much all it needs. So. That should do it. And then we'll clean the back of this off. Put that straw back on. All right. Yeah, so it slides into this groove here. See this little pin? So when this is fully loaded, it slides along this groove, and I think that's just getting gummed up. No big deal. It's an easy fix. If it works, it's an easy fix. Here we go. And while we're in here, we're going to just kind of smear a little bit of lubricant on all the little rails and anything that moves. Okay. All right. Let me grab a tissue, a napkin, or yeah, I got some tissues I can use. But yeah, it's one of those situations where it really doesn't work unless you try it a couple of times and then it starts to work again. So I'm going to just go ahead and, yeah, see? Now there's also going to be a micro switch, or a limit switch. It tells it when the disk is fully loaded in there. What did I do? Okay. There we go. Now that micro switch could also be misaligned. Although I don't see a micro switch anywhere. It could be built into the board. Let's take a look at that side of the... Yeah, there it is. So this is the load. This is the micro switch that tells it whether the disk is loaded or not. And that could be misaligned. So what I'm going to do is... I think what I'm going to do, rather than try to realign anything, I'm going to put a little bit of deoxit in there, which will correct any contact issues. So that stuff will work its way in there with time, and yeah, it'll work its way into that switch, and that's going to clear up any contact issues. All right. There is no way to realign this switch if there's a problem with alignment, because it's all kind of stamped to go in only one way. So, all right. Let's clean the board surface. We're going to clean up the volume. Now, these volume switches were also notorious for getting flaky. We spray a little bit of deoxit in there as well, and that should clear that up. In case you decide to hook up headphones to it. Some people do it. All right. So I think what we'll do is we will probably just replace all of these electrolytics. I'm going to mark these off. I literally have these on hand, so I'm not worried about that. We'll just put all new ones in. There we go. There's really not that many. There's only a couple. Everything I work on with this machine, I'm really going I'm going all the way to make everything just so. All right. I don't like that noise. It sounds really shitty. Okay. So what I'm going to do, we're going to take these gears off. And yeah, it's not worn out. It's just really shitty. But the thing with these Toshiba drives is they were pretty reliable. You know, I don't recall in my years as a computer tech having to replace a lot of these Toshibas, because they were pretty well put together. They just weren't the most precision loading units, if I recall. They were very noisy. And I only saw these drives in system builder pack type systems. You know, that's pretty much the only time I ever really saw these. You know, people weren't really buying these to put into their computers. They were buying, you know, the retail ones, but it's just, I guess that noise is inevitable, huh? Is it the motor making that noise? No, the motor sounds normal. It's just really crappy gears. That's what it is. So we'll dab a little more of our little grease. Maybe we can quiet it down. There we go. No. You know what? Oh. I think I figured out the problem. I think the problem is this nylon gear here. I think it has shrunk, and it's causing the gears or the teeth to misalign as they're meshing. There is no quieting that down though. It just sounds like shit. All right, let me pull this back apart, and I'm going to get this out of here. This should just lift right up, and we'll just holding it in. Look at this. Yeah, I think so. There's got to be, oh, I see it. There's a clip in there. Okay. So to get it out, it has to be aligned a little bit further in. Yeah. Is there a way to pull this out? Okay, so we got to take the this mechanism has to come out next and slid out. There we go. So we take this out. Now that can go all the way over, and it can be then lifted out of position. Take this screw out. I believe it should come out all at once. Let's see. Apparently not. I guess not. Maybe if I press that tab in, or is there another alignment position where it needs to be? Okay. Very interesting. Okay. Well, this is being a bastard. I think if I push down on this, no, I don't want to break anything. I think what I'm going to do, I'm going to put in a little bit of lubricant from the inside here. Yeah. Okay, so there's a little sliding point right in there. You want to shove some grease up in there. You want this thing to work as smoothly as humanly possible. And that lubricant, this is polyolefin grease. It will not affect the plastic. It will not degrade anything. If you use like a petroleum-based lubricant, you're going to wind up with plastic that begins to swell, or rubber, anything made of a petroleum-based compound like plastic. You're going to have you're going to run into some trouble. So that's the key point of that. So I'm going to go ahead and dab a little bit of grease on the moving components here and here. Okay. And we'll clean up the this end of it. A little bit of grease there. Why go through so much trouble for a 25-year-old CD-ROM drive, you might be wondering? Well, because there's just not a lot of these left. You know, in the grand scheme of things, they made millions of these things, and there's just not that many left because nobody really thought to save this kind of stuff. Very few people did, and those who did were more than likely collectors, and there's far few collectors than there were users. So and we live in a world right now where most folks are focusing their efforts on eliminating CD-ROM drives, even from classic vintage equipment. They're eliminating CD-ROM drives and floppy drives, and it's my goal to reverse that trend, to try to keep some of these old media formats alive. And I just feel like it's my calling. It's what I like to do. And so I'm very passionate about this. I want to keep this stuff going as long as possible. So that moves nice and smooth. Okay. Very smooth, very easy. Alright, so I'm going to start putting these gears back in place. This can go in first. Now it's the action of pushing the CD-ROM door, okay, pushing it closed, that forces the motor to go into the inject position. Because you'll notice when it's fully out, this motor doesn't engage with anything. Okay. Let's see how that goes. Let's put this back together, and I'm going to work on the controller. Okay, so we've got that guy there. Don't know where that came from. Where did this come from? Oh, that's from the capacitor that blew apart yesterday. So. Okay. Just gotta close this all up. Generally, what you're going to find with these earlier CD-ROM drives is that they're actually belt-driven, and those belts are what are causing your problems. Those are definitely a constant problem these days. And so, but doing this, yeah, that should be fine. Okay. Let's put it in the load position. All right. Let's put this back in. I'm going to go ahead and oops, let's not do that. Let's put it down. There we go. That does sound pretty bad though, doesn't it? Doesn't that just sound really bad? Like, really bad. Okay, I can't find anything wrong with it. All right, put this guy back in place. All right, that's pretty much it. So I'm gonna reassemble this, and we're gonna see what happens. All right, we've got all new caps on this board now. So doing a cap job on a drive like this, so let's kind of take it from the top here. So normally, in the old days, we wouldn't do anything to save a drive like this. This is just a basic run-of-the-mill builder grade, in other words, system builder level, just a cheap CD-ROM drive. It's nothing special. It's not a writer. It's just a reader. And normally we wouldn't try to save something like this or put any effort into it at all. And yeah, that is right. Why would we? Because these were a dime a dozen at one time. These were getting thrown away all the time. Everyone was upgrading to CD readers, and faster drives like a 24, 48, 52X. They were upgrading to CD-ROM writers, CDRW drives, DVD writer drives. I mean, these old-fashioned Toshiba or Lite-On or LG CD readers were just cast-offs. They were usually the first thing to go. And I include myself in that statement. I was always replacing these, tearing them out, putting in something better. But we've reached a point now where, these kinds of parts are getting very hard to find. So one must put some effort into actually trying to save them, as long as they're in good condition overall. So this drive was in very good condition, physically. And it showed signs of life, so I felt that it was a good candidate for an overhaul. So what we've done here is we've lubricated everything in the loader mechanism, and everything should be nice and lubricated. We've cleaned the lens. It had a little bit of a haze on it, dust and a mixture of dust and so as these components age, they begin to outgas. Actually, from the day they're built till the day they're crushed, they're always outgassing, chemicals from the plastic and lubricants and other components. So that stuff builds up on the laser lens like a cataract. So what you want to do is you want to clean that stuff off. It can only be done with a cotton swab. You can't just put a laser cleaning disc in there and expect it to work, because that just doesn't work. So you've got to go in there with a cotton swab and you've got to get it done. We've gone ahead and we've replaced the capacitors on the entire control board to get ahead of that problem, because this thing is now 25 or so years old, and you know, those are the first things to start giving you trouble. With electronics, it's always the caps. It's always capacitors. Almost, I'd say 80% of the time, when there's a problem, it's capacitors. You can pretty much count on one thing, two things, three things now. Death, taxes, and faulty capacitors in old electronics. So we went ahead and we replaced them all. I didn't need to build a kit because I already stocked these particular values for my car stereos. So I didn't have to go looking for caps. I had them on hand. So that was a nice, pleasant surprise. But normally, you're going to want to order, you know, a couple of values to have on hand. But anyway, enough of that. So let's get this thing reassembled. And I'm going to run these wires. So yes, to clean the laser lens, you actually have to desolder the load eject wires on this model. But no one ever expected this to be repaired at any point in time. You know, that was never a thing that they were considering when designing these. So it looks like I'm having trouble getting this cover on. It is, oh, I see why. Okay, so we're going to have to take this capacitor that I laid on its side. We're going to have to put it in vertically. Okay, there we go. Which means I'm going to have to go back in here and pull these up. Let's see. Got another one. Yeah, they're going to put them in vertically. There we go. We'll just straighten them out. There we go. So I was anticipating clearance issues, but I didn't. I was wrong. There's plenty of clearance vertically, just not sideways. So that's okay. All right. But let me explain. So some of the capacitors that I had to replace, I didn't have the shorties. I had the full length, you know, 7-8 millimeter ones. And so I put them on their sides, you know, thinking that it was vertical clearance that was going to be the issue, but it was not. So just a side note. So we're going to put this back together here. I'm going to put this, there's a cable missing here. There it is. Got that one. Put that in here. And put this one in here. Okay. All right. Now I'm going to go ahead and solder these. These are labeled. Oh, one little neat thing I found on this unit is the capacitor values are labeled on every spot. You never see that. You never see that. So it tells you 1647 or, yep, whatever the value might be. It tells you right then and there. No guesswork. It's pretty clever. Okay. Whoever did the artwork for this control board, they were thinking of you. If you're the service person, they're thinking of you. Which is kind of shocking. That never happens. So everything's hooked up. I can put the coverage on. Put the top cover. Okay, so this whole thing is held together by 4 screws. Make sure it all seats nicely. I feel like I'm missing something though, because I have there's a couple of machine screws. 3, 4. So there's 2 coarse threaded screws that I need to put in somewhere. Where do those go? 1, 2, 3. Oh yeah, right here. It's actually marked with an arrow. I like it when they do that. And there's one over here. Okay. And that's pretty much it. So now we'll put it back in the PC and see what's going to happen. If this doesn't work out, I have other drives to choose from, but I just wanted to try to save one of these generic builder pack grade. So I went ahead and installed it in the PC with a brand new IDE cable. I'm actually buying new IDE cables for this because, well, this is what I had. This is a rumpled ass Ultra ATA 66 cable that is just beat to shit, and it's not period correct. They didn't have Ultra ATA 66 in 1994. Well, 91 when this was built. 94 they might have. I don't remember when that came out. But anyway, 97 or so, 98. So anyway, I actually bought the correct cable for it, and I actually ordered a longer floppy cable so I can connect my 5 1/4 inch floppy drive. So let's turn this thing on and see what it does. Okay. Now the BIOS is going to have to be updated. That sounds good. Okay, F1 to resume. Standard. Yeah, this hasn't been run in a couple of hours, so we need to configure everything all over again. Hard disk size. It could be anything because we're running easy drive, so it could be anything we want it to be. Drive A should be 1.44. I have a new battery on order for this, and that should take care of that problem. So F10 and exit. Here we go. The BIOS does not support booting to a CD-ROM drive, so that's not something we can even do. All right, let's see how we did. I grab a couple of CDs. I got The Incredible Machine, Encarta 97, which won't work on Windows 3.1. So we've got Corel Printhouse, Oregon Trail, designed for Windows 95, but I think it'll work in Windows 3.1. It should. All right. Let's try Oregon Trail first. It actually sounds a little bit livelier. Yeah, I think we're good. So we'll open up the file man. Yep, it's reading. Auto run. Going to be upgrading the CD or the oh, I can't run this in Windows 3.1, huh? I think I can. Maybe. Yeah, graphics card needs to be updated. We're going to be putting a new one. I actually have more memory in order for this. Yeah, see, everything. Let's just. But it looks like we've solved the problem where it was actually you put a disc in and it wouldn't clamp down because it wasn't closing the door with enough velocity. That's what was happening. There was not enough velocity in that door close action to lock the spindle shut. So, or lock it onto the disc. And with new shiny caps, it's like we just rolled back the drive to a brand new state again. And that, my friends, is how you save a life. Or specifically a very old CD-ROM drive. So now I got to mount this thing back in, finish it all up. Thank you all for watching. All right, now's the fun part where we get to test all the capacitors we ripped out. Was it worth it? Did we gain anything? When I did the cap job on the Creative Labs sound card, what I found was the values hadn't really drifted from the original caps. They were still all very good. This might be a different story, but we'll find out in a sec. So this is a 6.3100 microfarad. $107. So this one is good. But while the capacitor values may still be in spec, they are nearly 30 years old. So that's something that cannot be ignored, and they will fail. It's just a matter of when. So 47. This one's really good. These are actually, so far, so good. Here's a 16 volt, 10 microfarad. I bet these are going to be pretty low. Let's see. 9.6, 11 ohms, 11.9, almost 12 ohms on ESR. This cap is bad. Mwah. Okay, we're getting somewhere. Let's try this one. 47 microfarad, 16 volt. Here we go. Perfect. This one is well within spec. Okay. This is a 220. What do we got? 227. This is really good. Okay, so far, things are looking favorable. 109. This should be a 100. That's amazing. They were using some pretty decent caps back on this drive assembly line here. This is a 100 microfarad, and we got a 100 microfarad. So, was this job worth it? Well, that one with the high ESR, that was going to cause us some problems at some point. 99 microfarad at 1 ESR, I'm sorry, 1 ohm, and this is rated for 100. Yeah, these are all well within functional spec. These are good. These are good caps, for sure. 220, 224. So they're testing, if anything, they're testing a little on the high side for capacitance, which is not a problem. That is okay. That is totally fine. But there we go. There we go. Was it worth it? Yes. For that 16 microfarad 10 volt that I found bad, I would say yes. It was worth at least looking at. But capacitors was not really a problem on that drive. Those are all in pretty good shape. But now they're brand new again. Now the drive can go for another 20 years. I'm serious. It probably will last another 20 years. So as long as we don't beat it up too much. And geez. All right. Catch you guys later.